So we are now moving on to lesson 3, and we're looking at making scaled copies. So here's 3 polygons. Obviously this page only has the first one, and we're told to draw a scaled copy of the polygon using a scale factor of 2. So the scale factor of 2 means I'm going to multiply each side by 2. So that means if I look at each side and I say, okay, so here's the length, whoops. So here's the length of A. I made it, it's pretty close. So what I'd want to do is actually, let's move this out here, and I'm going to want to double that. So obviously I'm going to be using some magic here that you can't use. So mine, of course, is going to look a lot different than yours when you make it, but the point here is that it's twice as long. Okay, and then I'm going to do the same thing again with the others. So here's the same length as that, and oops, let's move it over here. Whoops. I know, you don't know what I'm whoopsing. So, okay. I'm going to put it back on there. So here it is. And yes, I extended it a little bit further because it's so there we go. Now I finally got it to go where I want. So even though mine may look easier to begin with, obviously it's a little bit more difficult than we might have thought in the beginning. So here we go. I'm going to move that over here. So again, twice as long. And then I only have my one side left. Now, we talked about how you should probably be using an index card. That would make it easiest for you to draw the length or find the length and then double that length. See, I'm getting better at this as we move on, so hopefully the next two won't take as long. So it's a little bit off there, but there we go. My scale copy of 2. I've made it twice as each length is multiplied by 2. So the next one, I'm going to do the exact same thing with these, and each one of these is going to be twice. What? No, it's not twice as long. This one is using a scale factor of 1/2. This is right here. So that means I'm going to be taking each of my lines, and I'm only going to be using half of each one. So I'm going to, now again, using an index card, you'd be far better off because you could then see for sure. I'm really eyeing this at this point, but it should be pretty close. And right now, you know, we are just learning about these, so it's okay if it's not perfect. The point is, again, that it's about half. And then I'm just going to move this over here. Again, it's a little bit off, but you should be getting the general idea here. And the next one, what am I doing? Scale factor of 3/2. 3/2. Remember, that's the same as 1/2. So what I would do here in this one is I'm going to start it out the same way I did before. For the first one, I'm going to move that right over here, And then I'm going to draw another one that's about half of it, and then I'm going to put them together. It's about 1.5 in length. So, if you were using your index card, you would be getting the length of it, and then getting half the length, and doing exactly what I'm doing here. And again, I'm using my computer magic here that you won't have on your paper, but regardless, it's the process that's really the important part right now. And, you know, if we were doing this to make it sure it's perfect, we would be, you know, more concerned about the angles and all that. And again, I think some of my computer magic here is helping me with those angles. But this is just, remember, practice. So that's more or less where we're at. Okay, next. Quadrilateral A has these side lengths. Quadrilateral B has the shortest side length of 2. So if I were to line these up, my first one, A, has 6, 9, 9, and 12. And then B has 2 as the shortest. That means I need to go from 6 to 2. Remember, I'm always multiplying. I know that 6 times 3 is 2. So we're like dividing by 3, which is the same as multiplying by 1/3. So we're multiplying by 1/3. So 9 times 1/3 equals 3. Same thing again. 12 times 1/3 equals 4. Now I got to be careful here because the question says, what is the perimeter? The perimeter, of course, means that I'm going to add all of these together. 2 plus 3 is 5. 3 plus 4 is 7. Remember, I'm adding, so I can use that commutative property. 5 plus 7 is 12. There's my answer. The commutative property tells me that I can add in any order. Next, polygon on a grid, a scaled copy of polygon, perimeter of 30. So the first thing I need to do is figure out the perimeter of this. So it's 1, 2, 3 on this side, 2 down here, 1, 1, 2, and 1. So the perimeter means I'm going to add these all up. So 3 plus 2 is 5, plus 1 is 6, plus 1 is 7, plus 2 is 9, plus 1 is 10. So the current perimeter equals 10. I want it to be 30. So I know that 10 times 3 would give me 30. So that means my scale factor is 3. So that simply means I'm going to multiply each of these sides by 3. So the first side, I'm going to start with this one right here. 3 times 3, of course, is 9. So I want my first side to be 9. So I'm going to start at the same place, and I'm going to make it extend up to 9. So 1, 2, 3, 4, 5, 7, 8, 9. I know that didn't quite hit the bottom there, but it's close. So next, 1 times 3 is 3. So, you know, I moved some things around here. Let's take care of this. Move this back where it belongs. Sorry about that. A little confusion. Okay. I'm using tools on my Magic iPad here that I've not used before, so that's why it's a little difficult at first. So this is going across to 3. Next one, 2 times 3 is 6. So start here and go down 6, 2, 3, 4, 5, 6. The next one is 1. 1 times 3 is 3. So starting here, I'm going to go across 3. I am going to move these all for you. I know that they're not right on, but of course you'd be using a ruler and your pencil, so things would be a little bit different. And then my bottom, just like it should be, is 6 across. So I'm going to try and move these so they make a lot more sense, but you should be getting the general idea here. So next, and finally, Priya and Tyler are discussing the figure. Priya thinks that B, C, and D are scaled copies of A. Tyler says B and D are the only scaled copies. Do you think they are correct? Okay, well, let's see. Scale copy, remember, means that every side is multiplied by the same scale factor. So if I'm going to compare this side, so 1, so this side is 2, so it would be times 2. So 1 times 2 would mean this would have to be 2, so B is not. Let's look at A. I'm going to start with this same side again. 1 times 1, well, that means it should look exactly the same. It does not. And this last one, again, I'm going to start with this side. This is 2, so everything should be, every one of these original sides is 1. So it means everything should be 2, 2, 2, all the way around. So the only actual scaled copy is D. So that tells me that Priya and Tyler are both wrong.